All right, my friends, today we're going to graph a piecewise defined function. Our example is f of x equals 1/2 x plus 3 if x is less than 2, and 5 minus x if x is greater than or equal to 2. All right, so for graphing, if those two equations were by themselves in a function, like if I had f of x equals 1/2 x plus 3, I know what that graph looks like. That's the equation of a line, like mx plus b. So that would be just a quick sketch in my scratch work here. That's a line with a positive 3y intercept and a positive slope, so something like that. And then same thing with 5 minus x. I could think of that as negative x plus 5. And so that, again, just a quick sketch, has a positive 5y intercept, and this one has a negative slope, negative 1. So something like that. All right. So what makes this a piecewise defined function is it says it wants that purple graph of 1/2 x plus 3, but only if x is less than 2. So let's think about x less than 2. So treat your x-axis as if it's a number line, which it is. So if I asked you to graph x less than 2 on your number line, you would say, okay, it says less than, not less than or equal to, so I would put an open circle there at 2, and less than means to the left. Right. And that is the half of the graph paper that f of x would like us to graph 1/2 x plus 3. So I'm going to go up to the top here and just kind of remind myself. Let's see, here's 2, x equals 2. That's where x is less than 2. That's where it wants the graph of 1/2 x plus 3. And let's clean that off our graph paper. Okay, so same thing with my green pen. I'm going to say we want the graph of 5 minus x, that green line, but only if x is greater than or equal to 2. Okay, so again, greater than or equal to 2, the x-axis like a number line means greater than or equal to means I fill in the dot for the equals to. Greater than means to the right. Okay, so again, I'm going to go take some notes up top and say here's x greater than or equal to 2. Okay, so let's actually do a good job on our graph paper of graphing those lines. I'm going to go back to my line 1/2 x plus 3. That's got a y-intercept of 3, so I'm going to plot that point. And it's got a slope of 1/2. Okay, so remember that's our rise over run. So we're going to go up 1 and to the right 2. Okay, so from my y-intercept, I'm going to go up 1 and to the right 2, up 1 and to the right 2. Okay, and I could continue that pattern off to the left. Instead of going up and to the right, we could go down 1 and left 2. That would kind of follow that same pattern. All right, so let's just fill in that line. So that's my graph of y equals 1/2 x plus 3, just doing a little bit better job than I did over in my scratch work. All right, so likewise, let's go ahead and graph f of x equals 5 minus x, or negative x plus 5. So for this line, I've got a y-intercept of 5. And then for my slope is negative 1. So I'm going to think of that as negative 1 over 1. That means I'm going to go down 1 to the right 1. Down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. All right, so I'm going to fill in that line. So just, there's my green line, my f of x equals 5 minus x. Okay, so remember that our piecewise defined functions are kind of our Frankenstein graphs, where we only want to keep part of one line and part of the other, or part of one graph and part of the other. All right, so I'm going to go to my purple graph, that 1/2 x plus 3, and I'm going to make sure that I only have that line graphed on the purple half of the paper. So again, I'm looking back up here at my notes at the top of the graph paper. So I'm going to go erase the part of the purple line that's on the green half of the paper. Okay, so I'm going to erase all the way up until I get to right there at 2, 4. Same thing with the green line. I'm going to erase it when it's on the purple half of the paper. Okay, so we don't want that line there. Let's see if I can erase that. There we go. Okay, so I only want the green line on the green half of the paper. All right. And so that's basically our graph. I'm going to go cover that up with a black pen to kind of make that my final answer. Okay, but first, we need to figure out what's going on actually at x equals 2. Okay, so look up above the graph in my purple and green notes. The purple line has an open circle at 2 because it said less than 2, and the green line has a filled-in circle. And we're going to do the same thing with the lines on the graph. Okay, so at x equals 2, okay, right here at 2, 4 on the on the purple line, I'm going to put an open circle there. And on the green line, I'm going to put a filled-in circle. Okay, so the point on the green line belongs to the graph. The point on the purple line that I just did does not belong to the graph. Okay. And then from there, all we have to do is kind of make our answer official here. I'm going to just take this line all the way to the edge there. Actually, that didn't go well. Let's make sure we get that in the right spot. Looks good. And then same thing with our green line. I'm going to go fill that in with black. Okay, so the purple and the green, that was just kind of scratch work, and the black graph is our final answer. Let's see if we can kind of make the, there we go. Looks better. Okay, so that's our graph of f of x, and I do a quick spot check. My graph passes the vertical line test, which it should, and it looks good.